Hello students, and welcome to this lesson on base angles, midsegments, and medians. Our objective today is that we will identify properties of triangles, including base angles, midsegments, and medians, using journal notes. So before we get any further, what I want to talk about is the isosceles triangle. So an isosceles triangle is a triangle with two congruent sides called legs, and two congruent angles called base angles. So if we come over here, we can actually start labeling these. So we have our leg here. This is a leg. This is another leg, so those are congruent sides. Then we have our base angles, which will be here and here. And then obviously that's going to make this the base. And finally we will have our last piece here, and this is going to be called the vertex angle. So now we have a good little diagram of an isosceles triangle. And this is going to be our first introduction to the relationship between sides and angles. So the isosceles triangle theorem states that if two sides of a triangle are congruent, then the two angles opposite those sides are also congruent. So that's interesting. So that means that any time that you have legs which are congruent, then the angles that are directly opposite those legs, right, those will also be congruent. So that's actually pretty interesting. So our base angles and our legs have this relationship here. The converse statement of this, right, is when we say Q implies P. So first let's identify our P and Q. So we're going to use green here for Q and red here for P. So the P is normally starting off in our hypothesis position. So if two sides of a triangle are congruent, so that's our hypothesis, then two angles opposite those sides are congruent. So by writing the converse, we'll say if two angles opposite those sides are congruent, then those sides are congruent. So if two angles are congruent, then the two sides opposite the angles are congruent. So we have this very strong relationship here, right? This is actually a bijection, or something which is a biconditional statement. So we can say both. If two sides of a triangle are congruent, then the two angles opposite those sides are congruent, and conversely, if two angles are congruent, then the two sides opposite those angles are also going to be congruent. So it goes both ways. So then let's start using this information to actually solve some problems. Alright, so let's say that we're trying to find the length of a specific leg, right? So it looks like we've already got one of our legs here, 31, that's already given to us. So each leg, we've discovered one of them, no big deal, right? So we figured that part out. Now, what we need to do is we need to actually see what our other two legs are going to be, right? Because I have 5x plus 1 and I have 6x minus 5. Well, very handily, I know that these two legs are congruent to one another. So what that means is that we can actually take those two expressions, 5x plus 1, and because it is congruent, we can set it equal to 6x minus 5. Alright, so let's go ahead and start solving. So I'm going to add 5 to both sides, and then I have 5x plus 6 is equal to 6x, and then I can say minus 5x from both sides, and you get 6 is equal to x. So we've solved for x, and we're not quite done yet, right? We have to go a little bit further, and I need to find the measure of each leg. Well, really, I only need to find one of these legs because they're congruent. So I can just plug this in. 5 times 6 plus 1 equals 31. So I can say AB equals 31, or rather the length of AB equals 31, and then I also know that AC will be equal to 31. So those ones are pretty easy. Now we're going to get into something a little bit more interesting. In this problem, where I have R, T, and S, I want to find angle T. So let's take a look. So I want to find the measure of angle T. Well, I could already know, right, that this is x and 3x. And then that makes this as simple as 3x plus x plus x. And I know from my angle sum theorem, right, that these are going to be equal to 180 degrees. So then I have 5x is equal to 180, and then x is equal to 36, and I'm done, right? No, I have one more thing to do. I need to find the measure of angle t. So therefore, I need to take x, and I say 3 times x equals measure of angle t. And I know that x is 36, so it's 3 times 36. And so my final answer here will be that the measure of angle t is equal to 108 degrees. So always answer the question completely. Alright, now the second one is a little bit more difficult. We left some more information out. So we have to find x and the measure of angle c. And in this case, we have a is here, b is here, and c is here. So we're trying to figure out what the measure of angle c is. Alright, well, let's go ahead and just make an observation at first, right? I know by the fact that this is an isosceles triangle, because this is congruent and this is congruent, that will cause this angle to be congruent to this angle. So therefore, I can write 8x minus 2 here. So then I can go to my angle sum theorem, and I can say 2 times 8x minus 2 plus 7x is equal to 180 degrees. And this is just a shorter way of writing 8x plus 2 plus 8x plus 2, right? That's where multiplication is helpful to us. So then we can say 16x minus 4 plus 7x is equal to 180. We can combine our x terms, and we're going to get 23x minus 4 is equal to 180. And so then we have 23x is equal to 184. And then we go and divide, and x is equal to 8. Alright, and I'm done. Again, no, right? We need to go back and we have to find the measure of angle c. So measure of angle c, I have an expression for it now, is equal to 8x minus 2. And so I'm going to plug in 8 here. And so I'm going to get 8 times 8 is going to be 64. 64 minus 2 is equal to 62. And so I have the measure of angle c is equal to 62 degrees. Alright, so let's go ahead and move on to the next thing. We're going to learn about the midsegment of a triangle. So we're going away from isosceles triangles now, and we're going into just a general triangle. So I'm not going to actually treat this as an isosceles. And the midsegment is the segment that connects the midpoints of the two sides. So if I create a midpoint here, and remember that a midpoint is just going to be the exact middle of a line. So what this is going to do is it will create a line between those 2 points. And using the midsegment, we can actually state a theorem, and that is if a segment is a midsegment, then the segment is parallel to the third side and half its length. So then we can state that this segment would be parallel to this segment, and if we go ahead and name these, right, A, and then we'll call this B, C, and then D, E, then I can say that the DE length is equal to 1/2 the length of AC. And they're parallel. So this is a pretty handy thing. It'll allow us to do some pretty powerful stuff here in a second. So let's go ahead and do some examples. Alright, so first example, we're going to be finding ME. So we know that ME is the midsegment here because it is connecting two midpoints, right? A segment connecting two midpoints on the side, and a midpoint makes a segment into two identical congruent segments, right? So we know that M is the midpoint here, E is the midpoint here, therefore this is a midsegment. We can say that these two are parallel, and then we want to find the value of ME. but I know that the measure of ME is just equal to 1/2 of KL. Therefore, ME will be 10. Likewise, we can come over here, and now we're doing something a little bit more complicated, but it's still not all that difficult, right? We want to find the value of 3n. So, first, we make the note that 3n is equal to twice 54. And we know that because 3n, if we were looking for 54 here, right, we know that 54 is equal to 1/2 of whatever value 3n is. And so if we rearrange it, we get to here. And so we say 54 multiplied by 2, that's equal to 108. 3n is here. And then you have n is equal to 36. So again, pretty simple. It's the identification of the fact and remembering that a midsegment is going to be 1/2 of the third side. Alright, I know we're getting a little long in the tooth here, and this video is going a little bit longer than usual, but we have one last thing to learn, one more vocab word, and that is the median. And a median is a line segment that joins the vertex of a triangle to the midpoint of the opposite side. And so that's going to be our last vocab term for today. That was our last thing that was on our mission set there to learn. And so, if we are given a median, right, and we're just told this is the median, and then we're told that this is going to be 6, we want to find this length here. So this unknown length. So we know that the median connects to the midpoint. Therefore, we know that AM is concurrent to MB. Well, we already know what AM is, right? Then we know that MB is equal to 6. And then if we also wanted to find AB, then I can say that AB is equal to 12 in length. Alright, so your reflection activity today is that you're going to define and give a diagram of the following vocab terms: base angles, midsegments, and medians. If you have any questions, please let me know, and have a wonderful day. Goodbye.